A 50-meter rocket, 100 to 200 tons, no landing legs, no attachment points for transport, and SpaceX needs to move this thing across 2,000 kilometers of ocean, where waves can make it roll uncontrollably. Here's the thing. Falcon 9 had legs. Those legs gave you something to grab onto, something to secure. Starship doesn't. The hull is just 4 millimeters thick in sections. One wrong load during transit, you've cracked it. And that's before we even talk about breaking it from vertical to horizontal, which creates forces the vehicle never sees in flight. How do you engineer a ship to carry something that was never designed to be carried? Let's talk about why SpaceX painted themselves into this corner. And look, I say that with respect, because the logic is sound. Landing legs add 2 to 3 tons of dead weight. That's mass that can't contribute to payload capacity. When you're targeting 100 to 150 tons to orbit, every kilogram counts. The catch tower at Starbase handles landing now, so why carry legs at all? Makes perfect sense. Until you need to transport the damn thing. Without those legs, you've got no natural load-bearing attachment points on the lower hull. The vehicle's entire structure is optimized for axial loads during launch and atmospheric forces during re-entry. It was never meant to lie on its side. When you go horizontal, the load distribution completely changes. You're now dealing with bending moments the vehicle never experiences while vertical or in flight. Kiko Donev, SpaceX's VP, confirmed back in September 2025 that both booster and ship will be transported horizontally from Starbase to Cape Canaveral. And I know some people were hoping for vertical transport. It would have been cleaner, more space-efficient, like how Falcon 9 rides on drone ships. But here's reality. Without landing legs to secure the base, a vertical Starship on a moving ship becomes a 50-meter pendulum. Think about that for a second. Ocean swells in the Gulf of Mexico typically run 2 to 4 meters with periods around 6 to 8 seconds. Those wave frequencies could induce structural oscillations that a thin-walled stainless steel cylinder simply can't handle. You'd be asking for buckling, fatigue cracks, catastrophic failure. So horizontal transport isn't the preferred solution. It's the only solution that doesn't end with a destroyed vehicle. Now we get to the breakover fixture. The FAA's April 2025 environmental assessment mentioned it first, describing it as a controlled, supported drop from vertical to horizontal. That phrasing tells you everything. You can't just tip a 50-meter rocket over like you're felling a tree. The breakover process has to control rotation rate, support the hull at multiple points simultaneously, prevent any section from taking excessive concentrated loads. The forces here are brutal. Super heavy booster? 200 tons dry mass. As it rotates from 90 degrees to horizontal, the center of gravity traces an arc. Right around 45 degrees, you're generating maximum torque on whatever support structure is controlling the descent. The fixture needs hydraulic systems powerful enough to manage those dynamic loads while keeping rotation smooth enough that the 4mm steel hull doesn't buckle. We're talking precision-heavy machinery operating on equipment worth tens of millions of dollars. One miscalculation, and you've written off an entire vehicle before it even leaves the launch site. Once you've got it horizontal, now comes the ocean transit problem. Donev mentioned they're testing this with their fuel tank transport barge, currently named You'll Thank Me Later, which is very on-brand for SpaceX. The question becomes, How do you stop a 100 to 200-ton cylinder from rolling during transit? Because ocean waves don't just lift ships up and down, they induce roll, pitch, yaw motions. Even in relatively calm seas, a transport vessel will experience several degrees of roll. Without proper securing, Starship lying on its side could shift laterally with each wave. And given the vehicle's 9-meter diameter, even a few degrees of roll translates to serious lateral movement. A cylinder rolling just 10 degrees moves its center of mass roughly 1.5 meters horizontally. With that kind of mass shifting, you risk the vehicle gaining momentum and rolling further. SpaceX has two engineering paths here. Option 1. Add fixed securing points to Starship's hull. Hard attachment points specifically designed for transport loads. This gives you positive securing, but it means modifying every single Starship that needs transport. You're adding production complexity and creating potential stress concentration points on the hull, places where cracks could initiate. Option 2. Make the transport ship so massive that the cargo's weight becomes almost irrelevant for stability calculations. Container ships do this. They carry thousands of tons without individually securing each container beyond basic locking mechanisms. A sufficiently large, well-ballasted transport ship could absorb the dynamic forces from a rolling Starship without experiencing dangerous stability changes. Donev's comment about the vessel potentially being comparable to an aircraft carrier? That suggests option 2. A Nimitz-class carrier displaces around 100,000 tons. If your transport ship is in that range, a 200-ton booster represents just 0.2% of total displacement. The math starts working in your favor. My read on this? SpaceX will go hybrid. The ship needs massive scale for inherent stability, but you still need side partitions or cradles to contain the vehicle. These structures wouldn't bear the full weight. They'd act as guides and barriers, preventing lateral movement beyond acceptable limits. The deck itself carries the weight through distributed support systems, probably with curved surfaces matching Starship's hull diameter to spread loads evenly. You want to avoid point loading that could dent that thin steel skin. Here's where it gets really challenging. Donev specifically said they're starting with single-vehicle transports, then moving to multiple vehicles sooner than later. Carrying multiple Starships simultaneously means dividing the deck into separate zones, each with its own support and securing systems. 2 boosters plus 1 ship, that's roughly 500 tons of cargo. And where you position each vehicle fundamentally affects the ship's trim and stability. This isn't trivial. So what are we looking at for vessel specs? A ship capable of carrying 3 to 4 Starships horizontally needs about 200 to 250 meters of deck length. Width has to accommodate a 9-meter diameter cylinder plus maintenance access on both sides, probably 20 to 25 meters of beam. Displacement could hit 50,000 to 100,000 tons when loaded. That means significant draft and serious propulsion requirements. Speed matters too. Donev mentioned 4 to 7 days transit time from Starbase to Cape Canaveral. That's roughly 2,000 kilometers along the Gulf Coast and around Florida. To hit that timeline, you need sustained speeds of 12 to 15 knots, even when fully loaded. That's not slow, and it requires substantial propulsion. Probably multiple screws driven by diesel-electric systems, like modern cargo vessels. But here's what keeps me up at night about this whole operation. During every voyage, SpaceX will need continuous monitoring of several critical parameters. Hull strain gauges on the Starships to track any abnormal stresses. Temperature monitoring to ensure the vehicles don't experience thermal cycling that could affect material properties. Accelerometers to track vibration frequencies. Because if the ship's natural pitching frequency starts exciting resonance in a Starship structure, you could be accumulating fatigue damage without even knowing it. The history here isn't comforting. Back in 2016, a Falcon 9 first stage fell off its transport cradle during road transit, damaged the stage. And that was on land, where you have way more control. Ocean transport? Weather changes rapidly. Wave conditions are never perfectly predictable. A truck can pull over if something goes wrong. A ship in open water? Your options are limited. That's why inspection protocols will be absolutely critical. Before transport, every structural point needs verification. During transit, continuous monitoring plus regular visual inspections whenever sea state permits crew to safely access the cargo deck. After arrival, another complete inspection before the vehicle gets cleared for processing. We're talking potentially 48 to 72 hours of inspection work, bookending each transport mission. Donev's timeline, mid-2026 for first operations, gives them maybe 12 to 18 months from now. That's aggressive. They need to acquire or finish building transport vessels, get maritime certification from the Coast Guard, develop crew training programs, emergency procedures. All this infrastructure has to exist before the first Starship boards. What makes me think they can pull it off? SpaceX's iterative approach. The "you'll thank me later" barge is their test platform. They can validate securing systems, practice loading,